Okay, let's start going over the page 480 homework. First problem I have to do here is number 13. Log of 27 base x equals 3 over 2. Log of 27 base x equals 3 over 2. Okay, so you have log base answer equals exponent. Alright, and by the definition of a logarithm, base to the exponent equals the answer, so x to the 3 over 2 equals 27. Alright, do we want to know what x to the 3 over 2 is? No, we want to know what x to the first is. So because there's an equal sign, you can raise both sides to an exponent. You can't do that if it's an expression without an equal sign. So how do you make 3 halves a 1? What do you do by exponent property? If you raise it to another power, then you would multiply the exponents, so you use the reciprocal and raise it to a 2/3 power. So then you'd have to do that to this side as well, raise that to a 2/3 power. So that would make this side x. So x equals 27 to the 2/3. Right, 27 to the 2/3. Whenever you have a fraction exponent, whenever you have a rational exponent, there's two ways you can look at it. Let's do this. So that could be 27 squared to the 1/3, or it could be 27 to the 1/3 squared. Right, 1/3 is the root. Right, we've done roots. No exponents, so that's just breaking a fraction apart using the exponent property. So do you want to square 27 and then find the third root of it, or do you want to find the third root of 27 and then square it? The third root of 27 is 3, so x equals 3 squared, or x equals 9. Alright, number, let's try to make some separation here, 13, 19. Alright, so I'm just going to keep rolling, but make sure you remember that you can rewatch anything. Again, pause. You don't have to, you don't have to keep it going if you're going over the problem, writing it down or whatever. Number 19. Alright, so you got log base 7. So both sides are log base 7. X squared minus 4, and that equals log base 7 negative x plus 2. So because both of them are log base 7, that's like saying x to the 3rd equals x. Well, if the bases are the same, these are both log base 7, so the bases are the same. So it's, okay, I'll do this over here. Just as an example, if you had 3 to the x plus 4 equals 3 to the 2x minus 1, then the bases are the same, so x plus 4 equals 2x plus minus 1. All right, so then you could solve that. So this is the same property, principle, concept. They're both log base 7, so they can both cancel, so then you have x squared minus 4 equals negative x plus 2. Alright, so what do? Well, you have a square. There's nothing that's going to cancel it. So you have a squared x and you have an x to the first. You're going to make that in a quadratic equation. So you're going to add x to both sides, x squared plus x, and negative 4. So subtract 2. So add x, subtract 2. So that's minus 6 equals 0. So now you have a quadratic equation. So you got to factor that, see what the two solutions are, and then do both solutions work. You have to check for extraneous solutions like I showed in the video. I looked back at the video yesterday after getting a couple questions on the solutions of the inequalities and saw that, I guess I don't remember this from year to year, but for some reason I didn't do example 4 and didn't show that inequality part of the answer. So, sorry about that. So I'll do that while I'm going over these. Some people specifically asked in private message to do that. All right, so what two things multiply? So positive 3 times negative 2. So x plus 3, x minus 2 equals 0. So x equals negative 3 and x equals 2. Okay, so why does the book say that the answer is negative 3 and not 2? All right, you have to check for extraneous solutions. So you go back to the original problem and see, do either of these solutions make these logarithms undoable? Hey, somebody from first period just submitted something. Oh, looks like something late. I'm not going to say the name. So plug in negative 3. I forget what I'm doing. So negative 3 squared is 9. 9 minus 4 is 5. So log of 5 base 7. So when you plug in that, you get log of 5 base 7, right? So then you plug negative 3 on over here. So that's negative x. So negative 3 is positive 3. 3 plus 2 is 5. So that's log of 5 base 7. So that checks out. That's fine. That's good. So over here you put in the 2 and check the 2. 2 squared is 4. 4 minus 0. 4 minus 4 is 0. So that's log base 7 of 0. Okay. So 2, negative 2 plus 2, that's 0. So log of 0 base 7. Oh, so what's wrong with that? They equal each other. Well, is this possible? That is saying right there as a definition of a logarithm, that's log base b of x equals y. Translates to b to the y equals x. So b to the y equals x. Well, what's y? Y isn't here. So you're not looking at that. You're just looking at what is that? What does that equal to y? So that's 7 to the what equals 0. Right? Anything to the 0 power is 1. Anything to the first power is itself. Anything to a negative power is a fraction. So it's less. It's between 0 and 1. All right. So first of all, let's do that over here. Right. 7 to the 0 is 1. 7 to the first is 7. 7 to the second is 49. All right. What about 7 to the negative 1? Well, that's 1/7. 7 to the negative 2. That's 1/49. So it's 1/7 squared. Right. So what are these? The negative exponents, calculator. All right, so I'm doing a teaching thing here with this, making this longer. You can click forward to the next problem on YouTube if you don't want to watch this stuff because you understood this from the video and it made sense to you. But if you want to watch this, okay, stay with me. Hey, I didn't think of that till just now. You could fast forward. So that's 0.14. 1/49th. That's 0.02. Okay, so what's happening with these negative exponents? Because it makes it a fraction. 7 to the negative 100 is 1/7 to the 100th. All right, how do you put that in a calculator? 1 over I'm going to put parentheses just to make sure it does this right. 7 to the 100th. All right, so 3.09169041. It's not negative. E to the negative 85. That means error, negative 80. Move the decimal, negative 85, or 85 places to the left. That's what this means when you see it on a calculator. There's an error in the answer. They're expressing the answer basically like in a significant digits, scientific notation type thing, where there's a number in the ones place, but if you move the decimal 85 places to the left, there's 84 zeros in front of this 3. So this is a tiny decimal, but it's not negative. So these negative exponents can never make a number negative. So the things, so it'll also make it never make it 0. So you cannot take, and I said this in the video, you cannot take the log of a 0, and you cannot take the log of anything that's negative. No matter what the base is here, no matter what the base is, these can't be done. Okay, so hopefully some of you are able to skip past that and get to doing the next one. So y is, okay, so let me finish the answer there, right? So x equals 2, x cannot equal 2. That is an extraneous solution because when you plug it in, it doesn't work to something that's possible. It's not possible. This is going to be a long video. Upgraded my YouTube account so that I could add videos that are longer than 15 minutes, where I verified my YouTube account. But I still really don't want to do that. I got 21, 27, 29, 31, and 33 to go over, 5 more. All right, and I'm going to have to explain the inequality. Well, I basically just did kind of explain why when you check solutions or when you do what you have to do with the inequality ones, how that works. So I'm going to do that quick. When I get there, number 21. 21 is a word problem. I'm not going to do that right now. I might do that on a separate video. 27, log of x base 7 is less than -1. Okay, so this is just log of x. So from what I just went over, x on the side, kind of like when we did roots. You couldn't have negative square roots, solving roots in the last chapter. Same concept. X has to be greater than 0. It can't equal 0, right? And it can't equal anything negative. So that's a restriction on the solution set. All right, so then you're solving the inequality. So the less than, so 7 to the -1. So the base, you're finding x. This stays together so that the inequality symbol stays in the same direction. So x is less than the base and the exponent 7 to the -1. So x is less than 1/7. So now x is, why did I write equal to and say less than? That's crazy. All right, so this is number line. You got 0, you got 1. I just did over here, 1/7 is 0.02. So 1/7, that's 0.5, that's 0.1. So 0.02 is really over there. So x is less than that. So there's an open circle there. Sorry, I colored that in. But because x has to be greater than 0, there's also an open circle there. So the solution set is tiny. It's just between 0 and 1/7, but it doesn't include 0 or 1/7. So that's the solution set as a graph. I know that's, what's going on right there, a little difficult. I thought by putting 0 and 1 so far apart, that would help out, but let's try that again. So if 0 is over here, and 1 is over here, that's 0.5, 4, 3, 2, 1. So that's 1/10. So let's say you got, the answer has to be greater than 0, but it also has to be less than 0.2, whatever that 0.2 stuff is, right? So the solution set is that. So the solution is between this and this. So x has to be between, and these are always less than. How many times have I said that this year? In and inequalities, they have to be less than. 1/7 and 0. The lower number on that side, higher number on this side, and the equalities have to be less than. So that's explaining the and inequality solution set, right? And you'll have to do that for each inequality. 21. All right, let's go faster. Come on. 27. I No, that was 27. No, that was 27. Oh, I skipped 21. I went to 27. So 29. Log of x plus 2 base 7. Log of x plus 2 base 7. All right, I hope you're paying attention to how I read these and how they're said. You don't say log 7, 6x minus 3. It's log of. What are you taking the log of? You're taking log of 6x minus 3. And the base of it is 7. You're taking the log of that because that's what you're solving for. Okay? That's what you're solving for. Oh, that's all right. So just like number 19, they're both, log base 7. So you can cancel log base 7. So x plus 2 is greater than or equal to 6x minus 3. So inequality, keep the solution on the left. Keep x on the left, subtract 6x. Subtract 6x is negative 5x. Subtract 2 and subtract 2 is greater than or equal to negative 5. X is greater than or equal to negative 1. Okay, does that work? Is that okay? X is less than 29. 29. X plus 2, 6x minus 3. Negative 5x, negative 5, that's positive 1. X is then dividing. Man, I'm skipping steps, thinking about what's coming next instead of being focused on what I'm doing. So dividing by a negative, that makes the answer positive. Dividing by a negative flips the sign, so x is less than 1. Okay, now is that okay? Can you do that? All right, so you have to look up here. What's going to make that 0 or negative? So x plus 2 has to be greater than 0. Subtract 2, so x has to be greater than negative 2. Okay, but one of these is going to take priority over the other, so 6x minus 3 has to also be greater than 0. Add 3 divided by 6, so x has to be greater than 1/2. Right, as a little, sample number line of which one of those would take priority over the other. Negative 2 and greater than 1/2 plus 3, 1/2. Okay, so if you have 0 here, 1, negative 2. X has to be greater than negative 2. So it has to be over here. It can't go past that barrier that the open circle makes. Right? If the solution says coming from this direction, it would have to stop there. This one says x has to be greater than 1/2. So that's 0, that's 2, that's 1, has to be great. X is greater than 1/2. So 1/2 is it can't be 1/2, but it can be over this way from 1/2. All right, well, this solution takes precedence, or it has priority over this one, because if the solution has to be greater than 1/2, then none of this could be a solution anyway. So this one is irrelevant. You have to figure that out when you have when you're taking a log of two things. You have to figure out which one of these is irrelevant and which one of these is the one that I need. So because this is a less than, x has to be less than 1, but it has to be greater than 1/2. So x has to be less than 1, but x has to be greater than 1/2. All right, so the solution set is an inequality. Hopefully that clears that up with solution set. Okay, so I guess you couldn't see that. But that's what I did with that little graph. I didn't look at my computer screen to see that you couldn't see that. 21, 29. Let's not waste paper. Let's write on the back. 31. Log of 12x plus 5 base 5. 12x plus 5 base 5 equals, nope, less than or equal to log 8x plus 9 base 5. Log 8x plus 9 base 5. All right. So they're both log base 5. Okay, so let's do the what the restrictions on the solution set right now. So 12x plus 5 has to be greater than 0. Subtract 5 divided by 12. X has to be greater than negative 5/12. 8x plus 9 has to be greater than 0. Subtract 9 divided by 8. X has to be greater than negative 9/8. All right, negative 5/12, negative 9/8. All right, where are they? Here's 0. Here's negative 1. 6/12 is a half. So this is just to the right of a half. So the solution has to be greater than that. And negative 9/8 is over here. Right? Negative 1 and 1/8. So the solution set has to be greater than that. Well, if the solution set has to be greater than this, then none of these can be the answer. So that one doesn't matter, that one does. And it's only going to matter if the solution is a less than coming in this direction towards that open circle. If the solution, so you could wait to do this at the end. I suggest you do it in the beginning unless you're a very detailed remembering person and you're not distracted, because a lot of times people forget to even do this, and sometimes you get lucky because you didn't need it, and sometimes you don't because you did. 31. I just took up a lot of space for that. So the logs cancel. So 12x plus 5 is less than 8x plus 9 minus 8x is 4x minus 5 is 4 is equal to 4. So x is less than or equal to 1. All right, so it is less than, and this has to be greater than negative 5/2. So x less than or equal to 1 or greater than 5/2 and 5/12. Okay, and I'm going to say again, I said this last week or whatever when we were doing the roots. Don't give me your made-up ways of how to write things like this. I will not accept them anymore. In the beginning of the year, I gave you -1s and things like that because you needed to learn. Okay, well, if you're in this level of math, then you're in this level of math. Then I'd have to teach this level of math as if you were a math person, not as if you're just trying to get an honors class in your transcript so it looks good for college acceptance. I have to teach this as if, and I just don't understand when people don't look at it when teachers don't look at it this way. I'm not teaching this for your grade. I'm teaching this as if my students are going to go on to be engineering students in college, to be math majors, to be accountants, to be actuarial, to work in actuarial sciences and work for insurance companies, to be what else? Computer science, where you need this math. These type of professions where you need high-level math and you need to be able to do it. And if you're just here because your friends are in honors, and if you're just here because you want a transcript, then you're not going to be that focused and that intent and as intent about being excellent at the math. All right, I'm doing this one fast. I keep saying I got to go faster. Base 9, 9x plus 4. Okay, so base 9, so 9x plus 4, what are the restrictions on that? So 9x plus 4 has to be greater than 0. Minus 9 divided by 4, x is greater than negative 4 ninths. As long as I copied that right, 11x minus 12, good. Okay, 11x minus 12 has to be greater than 0. Plus 12 divided by 4, x is greater than 12 divided by 4, divided by 11. I don't even know what I'm talking about. All right, so those are the restrictions. So if it has to be greater than negative 4 ninths, negative 4 ninths, negative 4.5 ninths would be negative 1/2. And greater than 12 elevenths, that's 11 elevenths is 1, positive 1, so it has to be greater than positive 1 and 1/11. So that is the one that you're going to use, not that. And is it even going to matter? I don't know yet. So they're both log base 9, so 9x plus 4 is less than or equal to 11x minus 12. Less than or equal to. All right, subtract 11x, and I keep the variable on the left for inequalities, minus 2x. Cancel that. Minus 4 is negative 16, less than or equal to negative 16 divided by negative 2. Good to write that out because you saw that I made that mistake. That switches the symbol. So that's 1x, so x is greater than or equal to positive 8. So if it's greater than positive 8, then this didn't even matter, and you could have waited until the end because this is a boundary on the solution set going to the left to a little bit more than 1. Well, this is already more than 1, and it's only getting greater, so the inequality doesn't matter. Okay, that's all the homework. I talked too much, and it's a long video.